Hi, today we're going to talk about the beginning of topic 5, which is over probability and statistics. So this video is going to be just on the introduction to probability and probability models. First, we need to get into some vocabulary. There are 3 main words that you'll see throughout the entire chapter, and it's really important that you know what they mean to be able to interpret the questions correctly. So first is sample space. This is the set of all possible outcomes. This is going to be pretty important as we get into probability because you often divide by the sample space. We're going to see how that plays out in some visual models in just a second. A simple event is a single outcome that you get from one trial. So like if you're rolling a die, the number that you see that first time is a simple event. I've written down here just to kind of understand the scale of these words. Simple event is a element from the sample space, meaning if your sample space already covers all possible outcomes, one simple event must have an outcome that you had already considered. An event is a set of outcomes that you get from an entire experiment. So if I go back to rolling the die, if I decide to do that 20 times, my event should have 20 different outcomes in it, each of which is considered a simple event. So again, just to kind of help understand the scope of these, a simple event, that one outcome, is an element of the event, which is the set of all outcomes, and the event is a subset of the sample space, meaning, again, all the elements from the event had to have already been considered in the sample space. Next, we're going to look at some probability models. These are just visual tools that we can use to demonstrate the outcomes from an experiment, or later on we're going to use them to organize the probabilities of different events happening. So first in this is a Venn diagram. We're going to use an example of blood type for all of these probability models. So first I want to label the different outcomes that I am interested in. So in this case, we're going to label A for any time you have an event, a simple event where the type A blood pops up. And the second one is Rh negative. And that's the superscript that you'll see on blood types, positive or negative. So we're looking in particular for negative ones. The Venn diagram is a way to organize these events, especially useful when they overlap each other. It's possible to have some types that have both of these features together and some types that have neither. The box that you draw for your Venn diagram is the sample space. So it is important that your Venn diagram is surrounded by some kind of enclosed figure to represent the entire sample space or all possible outcomes. Then we're going to create some kind of shapes inside that represent each of the two events that we're interested in. So I'm going to use circles as we traditionally see. The first circle is for the event of a type A blood. And the second oval shape is going to be for a superscript of negative. So now we want to list within this box, which represents the sample space, all possible combinations of blood types and their positive, negative subtypes. Well, what I like to start with is the overlap. The only blood type that would have A and negative is A negative. The only remaining option for blood type A would be A positive. Inside the negative bubble, we're going to list all the other blood types with the superscript of negative. And anything that doesn't fit into either of these two bubbles or events will go into the sample space. So I've got 3 remaining blood types. And so if you've listed all of the different simple events, then this is your entire sample space. And in this case, it consists of 8 different outcomes. The next type of diagram that we're going to look at is the tree diagram. This is another way to organize your data. We often see this with probabilities listed, but for this case, we're just looking at our sample space and finding a way to organize all the possible outcomes Each time your tree branches, it should be based on one characteristic at a time to best organize your outcomes. So I'm going to organize it by first branching into the letter type blood. So from a starting position, your blood type could be A, AB, B, or O. And then from each of those is another set of branches which categorize the blood type as either positive or negative. And so in the end, the number of branches that we have is the number of possible outcomes we have in our sample space, which again is 8. If you had chosen to split it first as positive negative, the second category would be the letter blood type. So each of these would have 4 branches. And hopefully you notice that we still end up with 8 different branches. It's just categorized a little differently. All right, the last probability model that we're going to look at is the probability tables. This is another way that you can organize different categories that you can split your outcomes into. So I'm going to split again by the same way that we did the tree diagram, which is by letter and then by positive or negative. So across one of the axes, we're going to list all the possible letter types. And then on the other axis, we'll list that subcategory plus or minus. And then where those cross in the table is where you'll put the outcome that includes both of those features. This kind of table is going to be really useful as we get into probability, actually putting in the frequency of an event happening, because you can start to see when 2 events happened at the same time pretty easily by looking where the row and the column intersect. The way we'll write this notation is P for probability, and then inside the parentheses you're putting what event you're interested in. So I'm just going to call this event A as the one that we want. To find the probability of A happening in a simple probability situation is just the number of possible outcomes in which that event happens, divided by the number of outcomes in our sample space. It's really important to know that probability is talking about a percentage chance of something happening or the percentage out of the total, so it can only be between 0 and 1. In order for probability to be 0, that means the event can never happen. So if we go back to rolling die, I could say the probability of rolling a 9 is 0 because I only have 1 die, and it only goes up to 6. But on the other hand, if I wanted a probability of 1, it has to be something that is guaranteed to happen. So if I said the probability of rolling a number between 1 and 6, it would be 1 because every time I roll the die, I'll get a number between 1 and 6. It's also important to know, just kind of underlying everything you do, understanding that the sample space has a probability of 1. Because the sample space is supposed to already include all possible outcomes, there is no other outcome that could happen besides the sample space. 2 more probability models that we're going to use in this first part of the chapter. The probability of A or B happening. So this is really helpful, I think, to look at the Venn diagram. If we want to know what's the probability of having type A blood or negative, then you would add together all of the area where you had a type A blood or where you had negative, because we're okay with any of those responses. You add together the 2 sample spaces, but you don't want to include A negative twice. If I just simply add those together, I'm going to get it twice. So the formula for this is the probability of just A happening plus the probability of the second event happening minus the probability of both happening at the same time. And the reason we subtract that away is because it's already been accounted for when we added the 2 probabilities together initially. So it's just removing duplicates. The last thing is the complement of an event. if you see an apostrophe, it means that we're talking about the event not happening. So I read this as the probability of not A. So anything other than A. This is always going to be calculated as 1 minus the probability of A, because 1 is the highest possible probability, and the probability of A is the part we don't want in this case, and so it gives you the remaining probability of anything besides A. All right, that covers the first section of this chapter. We're going to come back with some more probability rules for 5.2. Thank you.